Welcome back into our lecture series. Today we're going to be speaking about matter classification. Why is it important to classify matter? The reason why it's important to classify matter is because if we know where it belongs, we can make very accurate predictions about how it's going to react and interact with other matter. In other words, we would know about its chemical properties and its chemical reactivity. So, here before you is a matter classification scheme. Everything on top starts with matter. Everything we see in observable universe belongs under the category of matter. Matter is defined as anything that has mass and occupies space. In other words, it's anything with density. Matter breaks into two major categories. It breaks into pure substances and mixtures. Pure substances is defined as matter that is uniform in consistency. In other words, it has identical chemical and physical properties throughout its entirety. In other words, matter is made up of only one thing. Pure substances can then be broken down into elements and compounds. Elements is simply matter made up of only one type of atom. Here are some examples. Hydrogen, even though it's diatomic, it's still only one type of atom. Oxygen, again, even though diatomic, only one type. Sodium, only one type. Chlorine, even though diatomic, only one type. And finally, carbon, that has only one type. In other words, anything that falls on the periodic table of elements, that is classified exactly as the word suggests, an element. Compounds, on the other hand, are basically matter that is made up of two or more different types of atoms. Example for it is water, hydrogen and oxygen, table salt, NaCl, carbon dioxide, carbon and oxygen, carbon monoxide, carbon and oxygen, and of course glucose, carbon, hydrogen, and oxygen. Elements can then be broken down into atoms and molecules. Atoms are simply defined as the smallest part of matter that can retain its chemical and physical properties. In other words, it's matter that is made up of only one particle. So for example, hydrogen, monatomic, oxygen, monatomic, carbon, monatomic. If it's one, it is going to be an atom. If it's anything other than one, it is going to be a molecule. Molecule is matter that is made up of two or more atoms of the same element. Notice how now hydrogen is diatomic. It falls under the category of molecules. Oxygen, again diatomic, falls under molecules. Chlorine, diatomic. Even carbon-60. Anything other than one is going to fall under the category of molecules. Atoms are then made up of subatomic particles. We have hadrons and we have leptons. Hadrons are particles that interact through the strong nuclear force. In other words, they make up the nuclei of things. Two examples of these are protons and neutrons. And of course, the other category is leptons. Particles that interact only through the electromagnetic forces and not through the strong nuclear force. So for example, electrons. Electrons belong in the subcategory of leptons. Going on the other side, mixtures. Mixtures are two or more substances in physical contact. We have two major categories that make up mixtures. We have homogeneous and we have heterogeneous mixtures. Homogeneous mixtures are mixtures that is uniform throughout. In other words, that mixture, just like pure substances, has identical chemical and physical properties throughout in its entirety. The only homogeneous mixture that exists are solutions. Solutions is defined as when one substance is dissolved in another. How are you going to recognize that? You're going to see a compound, let's say for example NaCl, and you're going to see the term AQ at the end, meaning aqueous. In this case, it means NaCl has been dissolved in water and it's now an aqueous solution of sodium chloride. Same thing happens with tincture. The only difference is that tincture, instead of being dissolved in water, is simply dissolved in alcohol. We're not going to see that many tinctures in class, but we're definitely going to see aqueous solutions. So once again, the only homogeneous mixture that exists are solutions, because the one substance is dissolved in the other and dispersed throughout, and you're going to recognize this by the term aqueous at the very end. On the other hand, we have heterogeneous mixtures. Heterogeneous are mixtures that are not uniform throughout. Since they're not uniform throughout, they do not have the same chemical and physical properties throughout its matter. And we're going to see in a subsequent lecture what are some of those chemical and physical properties. Heterogeneous mixtures have two main categories. We have colloids and suspensions. Even though they're both very, very similar, they differ in one small part. Colloids, just like suspensions, have exactly the same definition. These are solid particles dispersed throughout a liquid medium. However, the particle size for colloids is less than 1,000 micrometers. So what does that mean? Because they are so small, they will not precipitate out of the liquid medium under gravity when they're left undisturbed. Some examples for colloids include blood, milk, and fog. Blood, because you have solid particles such as red blood cells, white blood cells, platelets, and others, dispersed throughout a liquid medium, which is the plasma. You have milk. You have inside milk, you have solid particles such as proteins, you have calcium, you have minerals, you have other sugars, and they're all dispersed in a liquid medium, in water. The same thing with fog. Fog is aerosolized form of a liquid medium. You basically have solid particles such as dust, and you have water molecules that aggregate around it. That is your liquid medium. So fog is a colloid as well. And on the other hand, we have suspensions. Notice how suspensions and colloids have the same definition. Again, they're solid particles dispersed to a liquid medium, but they differ in their particle size is greater than 1,000 micrometers. So what does that mean? Solid particles will precipitate out of a liquid medium under gravity if left undisturbed. Prime example of that is clay and water. So if you put clay in water and you mix it carefully and you leave it undisturbed, all the clay is going to fall to the bottom, and you're going to have various clay particles being suspended in the liquid above it. That is an example of a suspension, and that's an example of a heterogeneous mixture. Now, one point I would like to clarify is with mixtures is what is homogeneous and what is heterogeneous. Remember, mixtures are homogeneous. The only homogeneous mixture that there is a solution. And I want to compare and contrast this with heterogeneous mixtures. So let's go to our trusty sketchbook and let's sketch it out. So the first one I would like to do, we have homogeneous mixtures, and on the other side we have heterogeneous. Okay, now remember what we said. The only homogeneous mixture that we have is, let's say, for example, a solution. So over here we have NaCl and aqueous. Now, imagine you take two samples from this homogeneous mixture from the top and the bottom using micropipette, and you actually compare these two regions over here. You would see that they are exactly the same. Because why? When NaCl particles are dispersed throughout this liquid medium, because they break apart, it is going to be uniform throughout, and it's going to spread out evenly. So if you look at the top and the bottom, it is going to be identical. It's going to be the same, and therefore it's a homogeneous mixture. Now, imagine the example we gave with clay and water. Notice how this does not form a solution, so I can't put AQ over here. But what's going to happen is gravity is going to precipitate it, we said, out. So most of it is going to fall on the bottom as a solid, and you're going to have these various bands over here, with different, particle density, all the way to the top where it's going to be almost clear. So now, if you take a sample from the top, and let's say a sample from right here, are they going to be the same? No, they're not. They're going to be very different. Because they're different samples, you say that they're heterogeneous. Therefore, they're not uniform throughout. So once again, homogeneous, they're uniform. Heterogeneous, they're not uniform throughout. Thanks so much for joining me. I'll see you in class.